Hello. This is the lecture for linear equations in one variable. All right, to solve an equation means that we're looking for the value or values that make that equation true. So to find this value, we use algebra rules to isolate the variable on one side of the equation. Here's a couple of examples. In this first example, it says to solve for x. When we see that, we're looking for the value that when assigned to x will make that equation true. To do this, we will isolate the variable x. So the first thing that we need to do is isolate the term that has the variable x in it. That's 2x. So we should add 7 to both sides. By adding 7 to both sides, we're able to eliminate the 7 from the left-hand side because negative 7 plus 7, of course, is 0. So then we have 2x equals 1 plus 7, or 8. And to get x all by itself, we're going to want to divide both sides by 2. When we divide both sides by 2, these 2's divide out, and we see that the value of x is 8 divided by 2, or 4. Okay? So we have found that 4 is the value that when assigned to x makes this equation true. Let's just check that. To check that, we're going to substitute that 4 back into the equation for x. So we want to find out, is 2 times 4 minus 7, is that equal to 1? Well, 2 times 4 is 8, and of course, 8 minus 7 is equal to 1. All right, look at the second equation over here. In this equation, we have x terms on both sides of the equal sign. We also have constant terms on both sides. Well, I think I'm going to try and isolate x on the left side, so I'm going to need to put both terms with x over on the left side. So in order to move this negative 2x over, I'm going to need to add it to both sides. Because when I add 2x to negative 2x, I'm simply left with 0. 5x plus 2x, of course, is 7x. Let's bring down that plus 3, and that will be equal to 6. Now this equation looks very much like the previous equation. We need to get the 3 moved over to the other side so that we have the term with x in it all by itself. So we will subtract 3 from both sides. And 7x is equal to 6 minus 3, or 3. And finally, we'll want to divide both sides by 7. We divide out on the left-hand side. And we see that when x is equal to 3/7, this is the value that makes this equation true. Shall we check it? To check it, we're going to put that 3/7 in back in for the x. So 5 times 3/7 plus 3, we want to find out, is that equal to 6 minus 2 times 3/7? Well, 5 times 3/7 is 15/7 plus 3. Is that equal to 6 minus, and 2 times 3 is 6/7? Well, I could put this into my calculator at this point, but let's just take a minute to review fractions. If I want to add 15/7 to 3, I'm going to need to convert 3 over to 7ths, or I'm going to need to multiply that 3 by 7 over 7. When I do that, I have 15/7 plus 3 times 7, or 21/7. And I want to see if that's equal to, now let's convert to 6 over to 7ths. So I'm going to multiply that 6 by 7 over 7. So remember that minus sign. 42/7. So 6 times 7, that's 42/7. minus 6/7. Now I can add these. 15 plus 21, of course, is 36/7. Is that equal to 42 minus 6? Well, 42 minus 6, of course, is 36/7. Yes, they are equal. All right. Let's get a couple of examples that are a little bit more complex. All right. In this first example over here, we're going to do the same thing, but we're going to need to simplify. We're going to need to simplify the equation first. All right. So the first thing I want to do here is to go ahead and distribute the 2 and distribute that -4 so that I can drop those parentheses. All right. So 2 times x is 2x. 2 times 3 is 6. -4 times x, of course, is -4x. And -4 times -5 is positive 20. And that's going to equal 8 minus 5x. All right. Let's continue to simplify. I want to combine like terms on the left-hand side of the equation. A like term, in this case, we've got a 2x and a -4x. Those are like terms. They both have the x in them. So 2 minus 4 is going to be -2x. The other like terms that I have on the left-hand side is the 6 and the 20. So positive 6 and positive 20 is positive 26. That still equals 8 minus 5x. And now we can see that after simplifying this equation, it looks very much like the previous one. We'll get the x terms on one side and the constants on the other. So let's go ahead and, how about if we add a 5x to both sides? And I can do this all at the same time. I know I'm going to need to move the 26 over to the right, so let's subtract the 26 at the same time. -2x plus 5x, of course, is 3x. These guys add out. The 3x is equal to 8 minus 26. Well, 8 minus 26 is -18. And then, of course, yeah, the x terms here add out. So 3x is equal to -18. We just need to do one more step here to get x by itself, and that's divide both sides by 3. And we find that x is equal to -18 divided by 3 is -6. Okay. Try this second example by yourself. Go ahead and pause the video for a minute. Did you get -18 divided by 11? That's right. solving an equation in one variable, there are three scenarios that may take place. In one situation, we will find that there is one solution that makes that equation true. In all these examples we just worked, we found an answer, one number that made the equation true. This is considered a conditional equation. It's conditional. It's conditionally true based on the value that we find. The second case that we might see is that there is no solution. Okay, this would be, so we would go through all the steps properly, but there wouldn't actually be a solution. We would not come up with a number that made the equation true. And in this case, we refer to that as an inconsistent equation or a contradiction. And then the third case we might see is that there's an infinite number of solutions. In that situation, any value that we come up with would still make the equation true, and we would refer to that type of equation as an identity. So let's look at a couple more examples. In this example here, let's see what type of equation this one ends up being when we solve it. All right, so we'll go ahead and solve it. I'm going to need to simplify first. Let me distribute that -3. So we'll have 12x minus 3x minus 12 is equal to 9x minus 2. Let's combine some like terms. Let's see. We've got a 12x and a -3x, so 12 minus 3 is 9x minus 12 equals 9x minus 2. That looks a little weird, doesn't it? Well, let's bring the x's over to the left. Let's subtract a 9x from both sides. And go ahead and we'll add that 12 to both sides. So 9x minus 9x, well, that's just 0, right? And then -12 and +12, well, that's also 0. Well, the 9x also adds out on the right-hand side, but -2 plus 12 is a +10. So what do we end up with here? 0 equals 10. Is that true? That is never true. That is never true. So in this case, we would say there is no solution here. This is not true. This is not a true equation. This one would be considered an inconsistent or equation or a contradiction. Consistent or contradiction. All right, let's take a look at this example here. Well, let's simplify by distributing that -3. So we'll have 12x minus 3x minus 12 is equal to 9x minus 12. And let's combine these like terms, 12x minus 3x. So 9x minus 12 equals 9x minus 12. Look at that. Obviously, those are the same, right? They're both equivalent on both sides of the equation. But let's just follow the steps and continue solving. Let's bring the x's over to the left. So we'll subtract a 9x from both sides, bring the constants to the right. So we'll add 12 to both sides. So what do we end up with here? 0 equals 0. When everything adds up. That's true all the time, isn't it? That's always true. For any value of x, that's always going to be true. Any value of x that we put in here is still going to make this a true equation. So here, we want to say that there is an infinite number of solutions meaning an infinite number of values for x that make the equation true, and we would refer to this case here or this scenario as an identity. All right, before we leave this topic, and this I'm going through it quickly, it is review for this course. Before we leave this topic, let's look at some applications. And when we're solving applications or modeling with algebra, what we're doing oftentimes is simply translating English into algebra. In this first application here, we already have the equation. The equation is given as a equals 8t plus 45. and then it's explained. It's saying that this equation gives the total amount of money in dollars. A is my total amount of money, right? Well, note that, that's what A means, okay? That Timmy has T weeks after his birthday, all right? So A here is the total amount of money. T is how many weeks it is after his birthday. We need to find out when will Timmy have $149, right? Well, the A is the total amount of money that Timmy has. So the A is going to be the 149. And T is representing the number of weeks after his birthday. That's going to be the when that we're looking for here. That's what we're looking for. So I'll go ahead and plug that 149 in for the A. We're going to say 149 equals 8T plus 45, and we're going to solve for T. So we'll subtract that 45 from both sides. So 104 is equal to 8T. Then we'll divide both sides by 8. And we'll see that T equals, it's late in the day, I'm going to put this in my calculator. 104 divided by 8, 13. So we just found that Timmy has $149 13 weeks after his birthday. Okay, let's look at another one. Solve. 5 less than 3 times a number is 19. What is the number? All right, often we want to think about the context of what we're dealing with. This one doesn't have a lot of context, but we definitely want to see what we're looking for. What we're looking for here is what? The number. We're looking for the number, okay? We don't know what it is. Since we don't know what it is, that's what we'll assign to our variable. We'll say that that number, we'll use the variable x, is x. All right, now we've got to use some good interpreting skills to figure out what this sentence is saying. 5 less than 3 times a number is 19. All right, 5 less than something. What does that mean? If we have 5 less than something else, that means we're subtracting 5 from it, right? So I might say that 5 less than something is going to mean subtract 5. Subtract 5. All right, the next part of this sentence is saying 3 times a number. 3 times a number. Well, if I were to translate that into algebra, I don't know what the number is, but we decided to assign it to x. 3 times it is going to be 3x, right? So 5 less than 3 times that number is 19. Well, usually means equals, and they're telling us what that equals. It equals 19. Okay, so there's the interpretation. Now we just need to write that as an algebra sentence. All right, well, we're subtracting 5 from 3x, so we want to say 3x minus 5, and we know that it's equal to 19. Okay, now we'll just solve for x. So we'll add that 5 to both sides. And we'll see that 3x is equal to 24. And then we'll divide by 3. And we find that x is equal to 8. Let's look at another application. This one is a little bit tricky. And this one says that Maggie is 8 years younger than Bart. In 9 years, the sum of their ages will be 28. We need to find out how old is Maggie now. All right, well, I think we're going to need to start by assigning some variables. There are things we don't know here. We don't know, well, the thing we're looking for is how old is Maggie, right? So let's start with that. we'll let M equal Maggie's age now. Okay. We also don't know how old Bart is, right? So maybe we'll let B equal Bart's age now. All right, so there's a couple of variables. Maggie is 8 years younger than Bart. Okay, that's something we can translate, right? Maggie, we've just assigned her age to be M. Okay, that means equal, right? And Maggie is 8 years younger than Bart. We assigned B to Bart, right? And if Maggie's 8 years younger than Bart, that means Bart is 8 years older than Maggie, right? So we could say that M equals B minus 8. Now, what else are they telling us here? So we've got an algebra sentence, so we could write that down. We could say M equals B minus 8. What else is going on? It says in 9 years, the sum of their ages will be 28. Okay, so in 9 years, the sum, well, that means we're going to add something, right? We're going to add something. What are we adding? We're adding their ages in 9 years. In 9 years, right? So Maggie's age now is M. In 9 years, Maggie's age is going to be M plus 9, right? When we add that to Bart's age in 9 years, if Bart's age right now is B, in 9 years, Bart's age is B plus 9. So Maggie's age in 9 years is M plus 9. Bart's age in 9 years is B plus 9. When we add them together, the sum is going to be 28. All right, so we've done some interpretation there. We've interpreted what we're told into algebra sentences or equations. Now, how can we go about solving this, right? Well, one thing I can notice right away is that I can simplify my second equation a little bit. Look at this. I got a 9 and I got a 9. I could simplify this to M plus B plus 18. I can combine those like terms, those constants. That equals 28. Okay. Now, what am I solving for? Well, what I really want to know is how old Maggie is right now, don't I? But I got this M and this B. I got both of them in there. I know that Maggie's 8 years younger than Bart. If I can find Bart's age, well, then I would know Maggie's age, right? That's one way to approach this. This sentence could also be written this way. I could also say that if I add 8 to both sides, look at this. I could also say that Bart is 8 years older than Maggie. That's true as well, isn't it? If Maggie's 8 years younger than Bart, B minus 8, then Bart is 8 years older than Maggie. Bart is going to be M plus 8. So maybe what I can do here is I can say, well, instead of M plus B, I could use this other expression for B here, and I could substitute that into the second equation here, right here like that. And then I could rewrite this equation all in one variable. Maggie's age now, M, plus Bart's age now, which is M plus 8. We'll substitute that in there instead. Plus that 18 is equal to 28. Okay, now we can do some simplifying and solving here. Let's see, I've got some like terms. I can add these two M's together, can't I? Yep, I can say that that's a 2M. I could also add that 8 and the 18. That'd be 26. So 2M plus 26 equals 28. Then if I subtract that 26 from both sides, 2m equals 28 minus 26, or 2. Divide both sides by 2. And I see that Maggie is only 1 year old. Oh, she's a baby. She's 1 year old. If Maggie's 1 year old, how old is Bart? Well, Bart is 8 years older than Maggie. So Bart is 8 plus 1, or 9. Okay, should we check this and make sure? Well, let's see. In 9 years, the sum of their ages will be 28. Well, in 9 years, if Maggie's 1 now, in 9 years, Maggie is going to be 10, right? 1 plus 9. Bart, if he's 9 now, in 9 years, Bart is going to be 18. Does the sum of their ages in 9 years equal 28? 10 plus 18 is definitely 28. So this one was a little bit tricky because, you want to just add 9 to their ages, but they're both, and we have to add 9 to both of their ages. Let's look at one more. After a 30% reduction, you purchase a mountain bike for $196. What was the price of the bike before the reduction? Well, let's assign the variable to the thing that we're looking for. What are we looking for here? The price of the bike before the reduction. Let's use x. Oh, yes, it says using x for the variable. So x, let's just write out. We're going to let x equal the price before the reduction. Okay, if x is the price before the reduction, let's see if we can write an equation that'll help us find out what that is. Well, what are we being told? Okay, after a 30% reduction. So what does that mean? Well, the original price was x, that's the price before the reduction, but then it's on sale, right? So we're going to take 30% off, so we're going to remove or subtract 30% of that price. Okay. Well, when we do math with percentages, we move that decimal over 2 places. So the 30% as a decimal would be 0.30. So x minus 0.30x would be this new sales price, $196. Now what we need to do is solve for x. Well, how do we go about doing that? Well, all we're doing here is combining like terms. Look, these terms both have x in it, but this is 1x, and the second term is 0.30x. And 1x minus 0.30x is 0.70x. That equals 196. Solve for x. We're simply going to divide both sides by 0.70. So we're solving already. We're doing it down here. So then x is going to be 196 divided by 0.70. I don't want to do that one in my head. $280. So the original price of this bike before 30% sale, 30% off sale, was $280. Okay, that ends the lecture for linear equations in one variable.